Right, hello there ladies and gentlemen, and welcome to today's video. And today we're going to go through something that I've been meaning to go through for a couple of months now, and it's something that keeps cropping up in messages in my inbox, and I figured today was a good opportunity to resolve it. So we're going to have a look at this little graph I've got here in a little bit, and for those of you, of course, who are wondering what we're talking about today, we are talking about BGA Rework Machine temperature profiles. Now, I've been getting a lot of questions about profiles, and one or two people have messaged me in regards to actually getting the profile from my machine. And you may have been surprised by my response if you were one of those people when I turned around and said no. And and it wasn't me being funny, but I genuinely have a reason for not giving you my profile, and I'm going to explain exactly what that is. So basically, the easiest way to explain it is that a BGA profile is essentially a roadmap for the temperature that your BGA Rework machine will go through during a BGA Rework process. And as I say, I've been getting lots of questions, and things like that about how to create profiles. Can people have my profile? And the thing is that profiles are not a one-size-fits-all solution, and I try to explain that in a concise way with a couple of lines of text, which hopefully go some way to explaining what I mean by that. But rather than sort of having to copy and paste that a few times and sort of waffling along a bit, what I actually wanted to do was create this video so that I can point you here, I can explain that, and then you can go away and hopefully at the end of this you'll be able to get some ideas how to create your own profile, what exactly everything means, and things like that. So that's what we're going to do. So as I said before there, it's not a one-size-fits-all solution, and it isn't. And I actually want you to understand what a profile is and how to develop a profile independently of me, independently of anybody else, and ultimately I want you to understand what you're doing. Because BGA Rework is indeed a complex process, and you need to understand exactly what it is that you're doing, and not just repeating it parrot fashion. Because anybody can punch numbers into Jovi PC Suite, anybody can punch numbers into the control panel of an Apache or the Jovi 8500 and things like that, and without any understanding of exactly what it is that you're doing, and expecting a good outcome when chances are, if that's what you're doing, you're not going to get a good outcome, and you're not going to understand why that is, because of course this profile's worked for somebody else. Why isn't it working for me? And hopefully this video is going to go some way to explaining that. One of the important reasons, of course, for understanding exactly what it is that you're doing is because you need some sort of appreciation as to how the BGA that you're currently working on responds. And what I mean by that is that not all BGAs are created equally, and some are very, very different from others. Of course, they're different sizes. They're not necessarily different shapes, but they do come in different materials that they're made out of. So, for example, the South Bridge on a PlayStation 4 is a plastic chip, and it doesn't respond very well to a lot of prolonged heat and tends to warp. So we have to find either a different profile for it, or do as I do and find it easier just to preheat with a bottom heater on a rework machine and actually use hot air from a wand, because I tend to find that works quicker and creates less stress on the chip and actually encourages it not to warp. But forgetting that for a moment, as I say, some are like the old Xbox 360 GPUs and have a silicon substrate, and then of course we've got the PS4s and the Xbox Ones where they're a very similar sort of thing, but they have like a metal exoskeleton out there which braces the BGA up. That metal does go some way to actually absorbing some of the heat we put into that chip. And then, of course, you've got the things like the RSX and cell processors from the old PS3s, which, of course, have a full integrated heatsink in there, which draws away a lot of heat that we put into the BGA. And without proper rework and care and attention in our profile, we're either not going to lift that successfully, we're going to damage the board, or worse, we're going to damage the chip. So, of course, it's very, very important, therefore, that we understand exactly what it is we're doing, exactly what a profile consists of, in order to ensure that we get a proper result that we desire. So, you need to understand how to develop your own profiles so that you can successfully rework these chips on your own with success, no matter what they are or where and when you are reworking. And the only way you're going to do that is if you understand exactly what's going on here. So, as I say, I don't like giving my profile out for those reasons. Because I don't want you just to go punching things palette fashion into a machine and expecting it to work. And some people, like me, as one or two have found out, are reluctant to hand over their profiles. And there's a few reasons for that, you know. Some people simply don't want you to learn. Some people just think that this should be a closed shop. They know how to do this, it's rather specialist, and they don't want anybody else to know what's going on. And I think that's not cool, you know. We all have to start somewhere. Let's learn together. Some people spend hours and hours and hours, much at their own time and expense, both financially and again through time, to actually develop these profiles on their own. And they don't just think that it's right for somebody to come along and take those from them. And in a way, you know, I can see where those people are coming from, but again, it sort of ties into the first person that they don't want people to learn. And to me, that's not cool. I want you to learn exactly what it is you're doing and why you're doing it, which is what this video is going to be about, of course. And profiles can be very, very different for the following reasons. So, you know, I'm not just telling you this just to sort of make it seem awkward and harder than it is. You know, these are real legitimate reasons for actually having to build your own profile on your own machine. And one of those reasons, of course, is your actual location and where your machine is. So the actual ambient temperature of your room, for example, where your rework station sits, can have an effect on your profile. Because if you live somewhere that's rather warm and hot versus somewhere that's cold and wet like in the UK, then that can also lead to differences in humidity, which basically encourages moisture into the board, and a humid environment with lots of moisture. And if we put too much heat too quickly into the board and BGA, then we can ruin things. And like I say, if you live somewhere that's very hot, then the actual board will absorb heat from the environment a lot quicker than what it will here. So you may find that you don't have to put as much heat into the board as what I may do. And in you doing so may result in your chips popcorning or damage to your board and other components. And again, I don't want that for you. Heating plate characteristics, of course, can be different between production runs of the same machines. Different batches of plates used in the same production running machines may be different. The supplier to Jovi, say for example, this week, may have used a different ceramic supplier than he did last week. That ceramic may conduct the thermal profile, so it may conduct heat and things like that, completely different to what the last batch did. You know, the machine that was built before yours may very well have used the last plate in that last batch. Yours may be different. Again, this is why BGA profiles need to be built specifically on your machine by you. And just going back to that humidity point on the expansion of moisture. Essentially, like I say, you know, these things are hygroscopic. They encourage moisture from the air to draw into themselves, especially when they're sat around dormant. So if they've been in a box in the attic because they're knackered, or they've been shoved in a drawer for 6 months and not turned on, then that can all encourage moisture to absorb into the substrate of the BGA. Likewise, if it's one that you've bought off eBay, it's probably been sat around in a cardboard box, in shredded newspaper, that's been sat in a cold warehouse for a couple of days, in Royal Mail's depot, or in the back of a van for 3 or 4 hours in the morning, while the courier company actually gets its arse out to deliver these things to you. All of which can encourage moisture into the PCB and the BGAs, and of course as soon as you try to heat that, then you're going to run into trouble. The main issue with humidity, of course, is popcorning. And what popcorning is essentially the moisture that's inside the BGA is heated. And of course, when water is heated, it turns to steam, which causes pressure inside the BGA. Now, if you build that up too quickly, rather than just safely leaving the BGA and evaporating out, if you do too much too quickly at it, then that pressure and that steam basically has to get out somewhere. And it goes through the path of least resistance. And that's basically up and through the layers of your BGA. And rather like watching popcorn kernels in a microwave, once it gets to that point, the BGA actually pops and you end up with little bumps all over the surface of it, and it doesn't look very nice, and as soon as you do that, then you've got a bad BGA and you can't use it. So you've got to replace the BGA. Now, in the case of maybe an Xbox 360, on a GPU or something like that, then that doesn't matter. But if you're doing something like a PS3 cell, or a PS4 APU, then those are per box and they're married and you can't change them, which basically means, well, you can change them, but there's a lot of headache in it because you've got to change everything else that's tied to it, which is expensive and time consuming. That's not something you want to do. So, that being in mind, and again, as I say, different heating plates between batches, so you can have two identical machines which run completely differently. And that can also be said for two machines identical in every single way in the same room, but they can both have different profiles for that very reason. So don't assume that just because a profile works for one person that it's going to work for you, because chances are it won't, or you'll at least have to do some tweaking to it to get it to work properly and in a desirable fashion. And as we also said earlier, don't forget about those different chip types. So, different, the silicon substrates, the plastic substrates, BGAs with integrated heat sinks, with exoskeletons, all of these are going to respond differently and each will need their own profile. Even BGAs of the same type. So say you've got an Xbox 360 GPU and an NVIDIA GPU die from a PC graphics card. They can both look identical, but both can respond completely differently to the same rework profile. So these all really need to be honed on their own, on your machine, by you. So I can't stress this enough because you will find profiles around the net. If you have a Jovi machine, you can even download basic profiles from Jovi's website. But I do urge you to use caution if that's what you are going to use, because at the end of the day, like I said, these things need to be tweaked, they need to be honed in on your machine. So if you are going to use those, practice with them first on a scrapboard and tweak them on your machine. Don't just jump straight into a board you care about that you've got to fix either for yourself or for the customer, because doing so is a big, big risk, and I can't stress that enough. So now we've got the basics out of the way, let's actually get into what constitutes a profile. And now we're going to have a look at this lovely little diagram I've got drawn here for you. So essentially there are 4 stages to a rework profile that you're going to want to think about. And essentially think of this as a graph. So what we've actually got here is the temperature in Celsius up and down this axis. Think of this origin point here as 0, so 0 seconds and 0 degrees C, and the time is basically going to run along the bottom there. Okay, so as I say, there's 4 basic sections to a reflow profile. So let's have a look at what they are then. So we've got one here that's preheat, then we go into soak, then we go into reflow, and finally we go down to cooling. So let's have a look at this first process then. So let's have a look at the preheat. Okay. So what preheat does is it takes us from the ambient room temperature, so whatever temperature your board is sat at while it's sat nicely on your desk or your table or whatever. And basically what it does is it takes us from room temperature up to a stable higher temperature. So what this stage does is it absorbs heat into the board that we are going to be working on. So it's important on multi-layer boards because, of course, multi-layer boards are built up of lots of different layers of copper. And copper is very, very good at absorbing and drawing heat away from where we're going to be reworking. So we're putting heat into the board, and the board itself is trying to absorb that heat out of where we're putting it. So what we need to do is we need to absorb as much heat as possible safely into the board so that it saturates the board. And it can't draw heat away, but instead it ends up building up in the area that we're interested in. So preheat is a very, very, very important part of the process, because without it, it means we have to subject BGAs to higher temperatures for longer to absorb necessary heat into the rework area, which can cause us to damage things like the BGA or the board, or kill the BGA altogether, which of course is not what we want to do. So that is what we use the powerful bottom heaters on our rework stations for. That's what we use them for. We use them to absorb heat into the board and the area we're going to be reworking. We don't really want to be using the top heater at this point to get the board to absorb heat at the preheat stage. We don't really want to be using it there, so no heat directly into the BGA from the top heater at this stage because it can just cause thermal stress. And what this does is it gently allows us to actually get the board up to temperature, and it allows any moisture to evaporate slowly and safely, which minimises our chance of actually popcorning and damage the BGA. So that's cool. Once we've actually got our preheat stage out of the way, then we actually move to the soak stage. And the soak stage is where we bring the BGA and the rework area up to temperature. So when we get it up close to the stage where we're going to be looking for that solder to melt. And we need to ensure this stage is done as quickly as possible, but without being too aggressive. And that's where something called ramp comes into play. Now anybody who's been doing a bit of research on this might very well have come across this term, and basically ramp is a property within a BGA Rework Profile which dictates how quickly the temperature is increased by the machine. So the machine will measure it. The machine will measure ramp as the temperature rising at the thermal probe. So of course we want the thermal probe as close to our BGA as possible. So it's going to try and ensure that the temperature at the probe is increasing at the rate we set. So the higher the ramp value, the faster the machine will attempt to raise the temperature of the rework area, and that's usually measured in something called degrees per second. And in our case, of course, in our diagram, we're using Celsius. So it's usually set between 1 and 3 degrees C per second, and default on the RE8500 as I use is 1 degree. So there's a happy balance here, because too high a ramp and you actually risk popcorning and thermal shock to the chips, because of course if there is any moisture in there and we're whacking a lot of heat and encouraging that heat to build up very quickly, we can rapidly evaporate any moisture in those BGAs and actually cause popcorning. Likewise, we can also cause thermal shock, and that will kill the BGA as well. So it's always a good idea to start at a lower ramp, and if you're finding that the profile's taking a long time or it's struggling, you can always increase it. So start lower and work up, work higher. So adjust it upwards until you reach a level you're happy with without the temperature rising too quickly and the process struggling along. So I tend to find that a good rule of thumb, 1 degree a second at the board level, I find works quite nicely and gives us, an average 2 to 3 minutes on that part of the cycle, which is ideal. And of course on lead-free profiles, where the melting point of solder is quite high, this sort of stage of the process will land around the 200 degrees C mark. Once we've got our board and our BGA roughly up to temperature, that's where we're going to enter this reflow process. The reflow is a part of the process where the BGA is actually brought up to its peak temperature. So again, one or two of you out there who's done a bit of research might have heard of this thing called peak temperature. And if you're wondering what peak temperature is, that's basically the point at which the temperature during the reflow process is at its highest. So in reality, we've got this little dashed line just here, okay? But in reality, it's probably a little bit earlier than that, because I like to think of reflow as the last little bit before it hits this top peak temperature. And this is where we'll sit for, say, 35, 40, 45 seconds or so, where the temperature is at its highest, and it's at this point where our solder will actually melt. So it'll melt here. So as part of a lead-free profile, this stage usually takes place around the sort of 200 to 225 degree mark. And the lead-free solder actually melts at 217. So we don't really want to go above 230. 225 I like to think is the limit that I like to subject anything to, so don't go above that if you can at all help it. And of course, during this reflow stage, and when we hit peak temperature, is where the solder will actually melt, and we'll hold it there for long enough so that that is where we'll actually do the lift. That's where we'll actually get our vac tweezer on the BGA and lift it. And of course, before we lift it, what you need to do is give it something called the nudge test, which essentially is get the end of a tweezer blade or something of that nature and just give the BGA a really tiny tap on the bottom edge and on one of the side edges to make sure it moves freely in both directions, which tells you, of course, that the solder is melted and that you're safe to remove it without pulling pads or points on the board or on the BGA itself. Once we've got the BGA off, of course, or we've reattached it using our profile, what we actually then need to do is bring the board down to temperature, and we need to cool it so that the temperature reduces from our reflow stage all the way back down to our ambient room temperature, so that everything is then nicely cooled off. So we don't want to do this too quickly because again we can cause thermal shock, we can cause cracking or drying of the joints, and of course then a repeat of the problem that we've just tried to fix by doing this process in the first place is likely to reoccur. So a good rule of thumb is to cool the board down, the BGA down by roughly 1 or 2 degrees a second till it gets down to around 100 Celsius. By that point the solder is well out of the way of its actual reflow point, and it's just then residual heat in the board, so that's when I actually like to add some induced cooling. So we'll add the cooling fan from the BGA Rework machine to actually get the temperatures down as quickly as possible back to room temperature. That's purely a time-saving sort of thing. So now you know what a profile is, and you've heard why I believe you should be creating your own. And you can see these different states now, and you know what ramp is, you know what the peak temperature is, you know what a preheat, a soak, a reflow, and a cooling cycle is, and now you know a little bit now about what each part of the process entails and why you need to be doing this yourself. We'll give you a couple of tips. Because of course, we're not going to give you any specific numbers because you're going to need to plumb them in yourself, but I am going to give you a starter for 10. So essentially, for successful BGA rework, you don't want your top heater to be any further than approximately 4 to 5 centimeters away from the surface you're reworking. So that is from the top of the BGA whilst it's sat on your PCB. If your chip itself has any integrated heat sinks, these need to be removed wherever possible. So if you're reworking PS3 BGAs, that needs to come off. Don't leave it on. PS4s or Xbox Ones, don't try to remove the exoskeletons, leave those on, but if it's got a proper integrated heatsink that pops off, then take it off. That will reduce any thermal stress, and either way, the thermal interface material underneath that underneath that IHS needs to be renewed anyway, because it doesn't respond particularly well to being overworked. The other thing to remember, of course, is that water evaporates to steam at 100 Celsius, so ramp things up slowly and hold them for several minutes here before you hit the soak stage. Bake any old boards sat around in humid conditions to ensure that you're not going to do that. Soak temperature, remember, wants to ramp at approximately 1 to 2 degrees Celsius a second, because any faster you're risking damage to the BGA itself, and any slower is just time consuming. The peak temperature, of course, is important. Lead-free solder is melting at 217 degrees Celsius and leaded at around 145 to 165 Celsius. So make sure your peak temperature is set accordingly. Cooling, of course, remember, good rule of thumb is to come down between 1 and 2 degrees per second to around 100 degrees Celsius mark, and then add any induced cooling from the machine to get it down to room temperature. And remember that these different types of BGA will need their own unique profiles setting up, so ensure that you do that to make sure that you get a successful process. And if you are using pre-prepared profiles, for God's sake, make sure you test and tweak them on scrapboards first before you go attacking anything that you care about. And with that, we will call that a nice introduction on BGA Rework Profiles. So thank you very much for watching, and if you do have any tips of your own, then feel free to pop them in a comment below. If you do have any questions, of course, you know where I am. And we will call that a day. So thanks for watching, and I'll see you on the next vid.